Welcome you all to the Spark Research YouTube channel. This is Dr. Vision, Assistant Professor in the Department of ECE, and this is the another very special session on this signal processing. And in this session, actually, we are going to talk about the very special topics, that is the 8-point DIT decimation in time FFT and 8-point DIF, that is decimation in frequency FFT. So both are belongs to the FFT, that is fast Fourier transform. So we will take the examples related to the decimation in time and related to the decimation in frequency. This is the very special session because this is very important. Okay. So let's go. First of all, whenever you are actually talking about the FFT, you must should be aware about the butterfly structure, that is how is it working. So in the butterfly structure there is input A and here is the output capital A. So how will you get this capital A and how will you get this small the input. So input, it will be given in your sequence like 1 2 3 4 any values, and here is the B is also input, and output how will you get. So A is equal to A, that is that this value A directly it will jump, and then plus here it is plus, and so multiply with this, right? So you are going, so B and then value whatever the values of W and T, so multiply B into W and T and then add A, so A and plus B W and T, right? So add this value, so this will give you the final value at butterfly structure. Similarly here, how will get A minus. So here whenever you are drawing now, here it will be multiplied by -1 always, right? So going down, multiply by -1. So here B is equal to A. So you are coming this way, A is this one, okay? And then minus, because of this minus, and what is that, wn, so b into w and t, right? So that will give the output at this point. So if you understand how to get the value of this A and how to value of B, then it will be now very easy for you. So we will change the value of this wn, and we can also change the position in DIT and DFT. It will depends on the type of the decimation, right? Another thing that you must have to understand, that is what is this W and K? What is the meaning of this W and K? So W is nothing. This is your exponential of minus J to pi n K divided by n. Capital N is the number of points. So 8 point means 8, 4 point means 4, 2 points means 2. And what is this N and K? N will be vary for your sequence. Maybe the for 4 points N will be 0, 1, 2, 3, right? And K is the value for what instant you are calculating, right? So some values you should remember, that is W and 0 it equal to 1, W and 1 equal to n is equal to for 4, this is n equal to 4, this will be value of this one. And similarly for W and 2, this is the value of this, and here W 3n for this will be. So these are the values that you should remember. If you remember, it will be very easy for you to solve the questions related to DIT or DFT. Okay. And one more important the things that you have to understand, the index values. So index, suppose the values are 0 1 2 3 4 5 6, but in binary how will you write 0 triple 0 1 2 3 4, like you can write, right? So 6 you can write 1 1 0. Now in the bit reversal, if you will see bit reverse index, then here now just make it reverse, triple 0 no problem, double 0 1, now it will be third bit will be the first bit, second bit, and first bit will be the third bit, right? So here it will become now triple 0 1 2 1 double 0, and value of 1 double 0 is 4, right? Similarly for 0 double 1, this will be 1 1 0 and bit will be 6, right? So here if you are giving the input 3, you will get the value of x of 6. So this is the important, right? So similarly, you can check the bit reversal. So this is the technique to get the bit reversal values. So you should remember all these three, right? first how to solve this butterfly structure, how to get the value of the butterfly structure, what are the values of wn0, wn1 and wn2, and what is this bit reversal. So you should remember all these three things. If you remember all these three things, you will solve the questions very easily. So let's solve. Now first we will solve the questions 8 point DIT DFT, that is decimation in time. So in order to solve the questions related to the decimation in time, first we will draw the butterfly structure of one, like four butterfly structures, because this is 8 point, right? So total how many inputs? 8, 0 to 1, 2, 3, 4, 5, 6, 7. So one butterfly structure, so we'll consider inputs from two inputs, so 2 2 2 2, so total 8 inputs. Now in stage 2, once we'll get the value at stage 1, then we will consider this output of stage 1 as an input for stage 2, and here the butterfly structure is of 2 cross 2, right? So here total it will be 4, right? So here again in stage third, now whatever the outputs we are receiving from stage 2, that will be the input for stage 3, and here we have to draw the butterfly structure of 4 into 4, so total 8 inputs, right? So finally, in DIT FFT, what are we doing? This is a signal flow graph for 8 point DIT FFT. So the 1 cross 1 butterfly structure, here 2 cross 2 and here 4 cross 4, right? So total how many butterfly structure? 4, 6 and 1, total 7 butterfly structure. So give the inputs now, solve the values at the inputs here, and finally you will get. So here if you will see, these are the bit reverse, these are the values, output values sequentially, these are the bit reversal values, right? So just go to the previous slide if you have any doubts how to find the bit reversal values. So in sequence, if it is given x0 x4, like you have to get the values of the inputs from there, right? And then once you will get the values at the end, right, here we are multiplying with the wn0 and why are we multiplying with here? Because this is DIT. So at DIT, in DIT we will multiply with these wn0 at the end. After multiplying here we will multiply, right? So here we are multiplying wn0 wn2 because this is 2 cross, and here we will multiply w40 w41 w42 w43, and here we will multiply w80 only, no? So no problem at all. Okay, so let's see the some example here. So here is the very good example. So your sequence is 1 2 3 4 4 3 2 1, right? So this is the x and 0, x and 1 is 2, x and 3, like that. Okay, so x0 and the bit reversal, these are the bit reversal values. Check the bit, how to find the bit reversal in the previous slide. So x0 is equal to how much? 1. It is given. X4 is equal to how much? Here 1, 2, 3. X4 is this 4. And x3 is only 3. Okay. And x6 is 3, right? X6 is the 2 1. Okay. X7 is 1. X7 is 1. So all the values you can get from the sequence, put it, and then step second is solve using the 1 cross 1 bit. So here w80 is here, multiply and get the values, right? So here 1 into 4 is there, so 4 in, so 1 plus 4 into 1, so 4, so 1 plus 4 is equal to 5, right? So here 1 plus and 4 is equal to 5. So this is the what in output of stage 1. Now this 5 will act as an input for stage 2, right? So here is the stage 2. So here what we'll do, here again this will be the input, and draw the 2 cross 2 and solve. Now w80 and w82, and here w82 and w82, right? So these are the values, and how will you get these values? W80 w81 2, already we have calculated these values, right? So w81 w82 w83 and all these values. Now draw and continue this process, you will get the final values like this. Okay, So here is another example. Here, if you will see here, this is a very simple example. So x0, suppose the input values is this one 0, 1, 2, 3, 4, 5, 6, 7, right? So x0 is equal to, like here 0, x4 is equal to 4, this is x4. So x2 already, all these values are given. Put all these are the inputs. Now minus, already whenever you are moving towards the up, you have to multiply by the minus 1. Okay, so whenever you will multiply minus 1, now see here 1 into minus 1, and here it is nothing, that is 0 plus the 4 into 1. So 0 plus 4 is equal to 4, and here 2, and here 6 into 1. So 2 plus 6 is 8, right? And here how are we doing at this point? So here that is 4 into 4 into minus 1, so minus 4, and here it is 0. So 0 plus minus 4 is equal to minus 4, and here 2 into and 6 into 1 minus 4. So 2 minus 6 is equal to minus 6. Similarly 1 into minus 5, that is equal to minus 5. Okay, so similarly you can solve. Now this will be act as an input for the second stage, and again you have to multiply minus 1 always. Whenever you're going lower, you can keep on multiply by the minus 1, and here the values are w0, w1, w2, w3, right? So you can remember the values of these values, already we have got. Now here it is 1 minus j, already if you'll see wn 4, and wn, like if you are coming down, no need to multiply. Coming up, then you have to multiply wn, that is w40, this is w41, here w80, w81, w82, and w3. So keep on doing these things till the end, you will get the final value of the x0 to x7, right? So check it and solve it, right? So we are running quickly. Similarly, we will solve the questions related to the 8-point FIT, FFT, right? Frequency decimation in the frequency. So here now if you will see, the difference is that in the DIT we are solving, that we are keeping first the 1 cross 1 butterfly, then 2 cross 2, then 4 cross 4. Just make it reverse here, 4 cross 4, then 2 cross 2, and that 1 cross 1, right? So again the same process we are going to take, like just a bit reverser will be the output. Here in the DIT we have bit reverser in the input. Here inputs you can give as usual, like 1 2 3 4 5 6 7, and the output will be in the bit reversal, right? So solve the same process, like inputs and then 8, keep on adding, multiplying w. So here the you have to multiply w0, w1, w2, and w3 at the end, not in the beginning. And then here w80, w82, and here also w80, w82, and here you have to multiply, the 1 multiply 1 not, 1 multiply 1 not, like this whenever you are going down, right? So w80. So this is the technique. So here is the one solutions, how will you solve the one question. So the inputs are 1 2 3 4 5 6, like that inputs are given. So keep on multiplying and get the values in the every step. So if you solve, you will get the final values, right? So check the problems. If you have any doubts, let me know. Thank you to join the session.